Okay, so this video we are going to discuss parametric equations, and also later in the next video we are going to discuss also about how to apply the differentiation of parametric equations. Okay, so let's have a look at the learning outcome for today. Okay, so you need to know how to find and use the first derivative, that means the differentiation of a function which is defined parametrically. Okay, so what is the meaning of parametric equation? Alright, so for parametric equation is they actually try to separate x and y into two different equations. Okay, and the f and g are functions of a variable t defined for some domain of value, and then we call this pair of equations as parametric equations, and then the t is actually a parameter. Alright, so last time when we learned, we are actually having y equals to something x. Okay, y equals to fx. But now they try to separate y and x into two different equations, and then we have a parameter t, all right, in both equations here. Okay, so we call this pair of equations as parametric equations. All right. Okay, so let's have a look for example 18. Let's try to understand, okay, what is the basic idea on the parametric equation. So let's say they give you x equals to 5t squared, y equals to 10t. Okay, so what is the coordinate of the point when t equals to 6? So it is actually very simple. When you are having t equals to 6, right, to get a coordinate, you just substitute t into the equation for x and y. So when you substitute 6 squared into the t, and then you will get 180 for the x, and therefore for the y, you substitute the t again into the equation of the y. So from here you'll get y equals to 60, which means that the coordinate of the point is actually 180, then 60. Okay, so this is how, what is the meaning of the parametric equation? That means they separate the x and y into two different equations, and both of them are having the same parameter, which is the t. Right. Okay, so let's have a look for part number 2 also, part B. Okay, so when t equals to -1, what will happen to your x? So again, the same thing. You substitute -1 into the x equation. You have a 5. And after that, what is the value for y here? 10 multiplied with -1. And therefore you will get -10. And therefore the coordinate when t equals to -1 is 5 and also -10. Okay, so this is what you have a simple definition on the parametric equation. Alright, so I hope that you know if you want to find the value for x and y, you need the value of t to find out the value for x and y. Okay, and again the t we call it as a parameter of both x and y. Right? Okay, so let's continue for example 19. Okay, so if let's say for example 19 again, they give you the parametric equation. And then here they define the domain of t. So t is from 0 until 2 pi. What is the value of t at the point 0 and 2? So just now you straight away substitute the t to get the coordinate for x and y. So now they want you to do the opposite way. That means they give you the x and y value. Alright, they give the x and y value and they want you to find the value of t. So again, you do it in the opposite way. So that means you start from the x equation first. Okay, so your x is equals to 0, right? So 0 equals to 2 cos t. Okay, so you're having cos t equals to 0. And then from the graph of cos, so you have to imagine the graph of the cos. So for the graph of the cos, you have 0, cos t equals to 0 when t equals to pi over 2, and also t equals to 3 pi over 2. Okay, because they're asking for 4 quadrants, one circle, right? One cycle. So the answer for cos t equals 0, you should have 2 answers here, pi over 2 and also 3 pi over 2. Okay, so for this question, although they want you to find the value of t, right? By solving one equation, it is not enough. You have to solve both equations. Then only you find out the overlapping answer. Alright, so again, after you solve for the x, you need to get for the y. So y equals to 2 sine t. Okay, so what is the value for y? It is equals to 2. So you're having 2 sine t also. So sine t is equals to 1. And also what's the value for t here? So again, you draw the graph for sine. So when you try to draw the graph for sine, right, you'll get sine t equals to 1 at the t when the t equals to pi over 2. Only one answer. Alright, so after you get the t from both equations already, then the final answer that fulfill both equations will be taken. So you will see that what is the overlap answer? The overlap answer will be pi over 2, right? So that means the answer for the t is pi over 2 only. Okay, it must fulfill the both equations. So t equals to pi over 2, then you will get the coordinate 0 and 2. Alright, so this is something very basic. Okay, so something very basic about the parametric equation. So just make sure that you know how to get the x and y coordinate if they give you the value of t, and also how you get the value of t if they give you the coordinate of y. Right? Okay, so this is what we have for example 18 and also 19. Okay, so let's continue further. So now when you want to extend the idea to differentiation, right? Generally, when you want to find the differentiation, the dy dx for any parametric equation, then you have to use the chain rule, which is, okay, so they want you to find out dy dx. So how the dy dx is equals to dy over dt multiplied with dt over dx. Alright, so this is what we have, dy over dt multiplied with dt over dx. So you apply the chain rule formula to get the dy dx. Okay, so the idea is quite simple. So you can have a look for example 20. Okay, so let's say I'm having x equals to 2t power 3, y equals to 4t squared plus 1. So how can I actually change it? How can I find out the dy dx actually? So the step is quite simple generally. First, you find out the dx over dt first. So when you try to get the dx over dt, you should have 6t squared. After that, you can also find out the dy over dt. So when you try to find the dy over dt, what do you have? You have 8t here. Okay, and then final answer, they want to get dy dx. So to get the dy dx, the chain rule is dy over dt multiplied with dt over dx. So what is dy over dt? 8t. What is dt over dx? 1 over 6t squared. Alright, so from here, you will get the answer 4 over 3t as your dy dx. Alright, okay, so please take note that for parametric differentiation, when you try to get the dy dx, your answer is in terms of t. It's in parameter, in terms of t. Alright, so again, you need to have the value of t to solve for all the application question later. Alright, okay. So for parametric, maybe you can try on your own. Okay, the answer that you should get for dy dx should be 1 over 2 e power 2t. Okay, so you just apply the chain rule that I showed you just now to try and get the answer. Okay, so for the differentiation of parameter equations, parametric equations, generally will not be hard. It is quite simple actually if you know how to apply the chain rule correctly. Okay, all right. So now, before I continue to the next part in the application of the parametric differentiation, maybe I will want to go back to our example on top. Okay, let us talk about the parametric equation more. Okay, so this is the parametric equation, right? Okay, so you see that x also got t and then y also got t. How can I combine these two equations together so that the t disappear? That means you get back the original equation that you learned all the while. If you want to combine two parameter equations together, become the equation y in terms of x, then generally you just need to try to think how to make the t disappear in both equations. So let's say for this one, I will assume that this is equation number 1. And then for equation number 2, okay, so t is equals to y over 10, right? So this is equation number 2. So you sub 2 in 1. Okay, so what we have is x equals to 5 and then y over 10 squared, t squared, so 5t squared. Okay, so when you try to simplify, you're having 5y squared divided by 100. And if you try to simplify it, you'll get 20x equals to y squared. So this is your original equation actually, y squared equals to 20x. But when they try to split it become the parametric equation, then it will look something like this. Okay, so usually in exam, if they give you the parametric equation, so you just use the parametric differentiation to solve the answer. Because I believe that most of the time, right, they will actually give you the value of t straight away. If you want to change it become the original equation, then only you do the differentiation also can, but maybe your step will be slightly longer because maybe the question, the value that they give you is a t, not x and y. So you have to find x and y based on the t first, then only you can continue the solving for solving the question. All right. Okay, so but no matter how, this is some extra knowledge for you to know how actually can you combine two parametric equations together, become the Cartesian equation that we learned all the while. Okay, all right. So for this parametric equations partner, it is quite simple actually. Okay, so let us continue with the application. All right, so again, just like what you learn in implicit differentiation, when you are having the parametric differentiation, right, it seems like not so hard, but when you apply it in the application question, because you need extra value such as t, therefore sometimes the question will looks a bit complicated. Okay, it depends on your luck. Sometimes the question can be very simple from this part, okay, but sometimes it can be quite hard also. So we'll see how. Okay, so let's have a look for example 21. I'm having two parametric equations here. Okay, so first they want you to express dy dx in terms of t, and after that they want you to simplify your answer. Okay, so maybe we can start. All right, so maybe I write it here. Okay, so what is your x? X is equals to 4t divided by 2t plus 3. Okay, so to find out the dx dt, because this is a fraction, therefore I need to apply the quotient rule. Okay, so when I apply the quotient rule, what will happen? It will have, you have 2x plus 3 square, bottom you square it, copy the bottom, differentiate the top. So differentiate the top, you have a 4. And then minus, copy the top, differentiate the bottom, which is a 2. Okay, sorry, I make a mistake here. This one shouldn't be 2x plus 3, it should be 2t plus 3. Okay, then after that, you try to simplify it. See how can you simplify it? 4 times 2t is 8, and 12 minus 8t. Then you should have 2t plus 3 squared. Okay, so if you try to simplify further, then what you have is you should have 12 only. So 12 divided by 2t plus 3 squared. So this is your dx dt. Okay, and after that, I want to get my dy dt. So y is 2 ln 2t plus 3. So to get a differentiation for y over dt, so 2 is a constant, you just copy. You bring the bracket in the ln down, become 2x plus 3. You differentiate the thing on inside the bracket, which is 2. And then overall, you're having 4 over 2t plus 3. Okay, so after this, what are you going to do now is you need to get the answer for dx over dy. So to get dx over dy, dy over dx, so the answer should be dy dt multiply with dt over dx. So what is du dt? 4 over 2t plus 3 multiply with dx dt. So you should have 2t plus 3 squared divided by 12. Okay, so if you try to simplify it, I think this one is quite simple. Okay, so 4 cancel off, this one cancel off, you have a 3. This one power 2 cancel off with the power 1 at the denominator. So if you rewrite your answer, you will see that this is what you get. 2t plus 3 divided by 3. Okay, so this is your dy dx. first part. Okay, so again, all basic rules for differentiation, you need to be very clear about it so that you can apply all these up in your solution. Okay, then now let's continue. Find the gradient of the curve. Okay, so at the point for which x equals to 1. Okay, so here they said when x equals to 1, what is the gradient of the curve? So the gradient of the curve means dy dx. So they want to know the dy dx value when x equals to 1. Okay, so how can we do that? All right, so first, maybe I put it here. Okay, second part in green color. Okay, so since I know that x is equals to 1, right? So maybe I will use the x equation, a parametric equation for x. Okay, so x is equals to 1. So you let x equals to 1, you substitute into the parametric equation. And if you continue to solve it, you should be able to get t equals to 3 over 2. Okay, so when you get the value for t equals to 3 over 2 already, then you just substitute it into your dy dx to get the gradient of the curve. So 2, then 3 over 2 plus 3 divided by 3. And therefore your dy dx is 2. So this is very simple actually. Okay, this kind of question is very simple. Okay, straightforward. Alright, just that you need to find the value for t first from the value of x that they give you in the question. Okay, then after that you can try a harder one. So the harder example will be example 22. Okay, so usually when all the differentiation try to involve trigo, usually it will be a bit tough because you need to apply the identity also where suitable. Okay, so first part, let's show that dy dx is equals to t. Okay, so how can we do that? First, you are having the parametric equation x equals to 1 over cos power 3t. Okay, so in the exam, if they give you 1 over x power 3t, no need to go and change it, become other identity whatsoever. Right? When they give you this pattern, they want you to use this pattern to do the differentiation. Okay, if you try to change it, become secant square or maybe some other things, then you might not get the differentiation answer correctly. So you just stick to what they give you and then you continue with the differentiation. So what they give us is a fraction, 1 over cos power 3t. Therefore, when I want to do the differentiation for x, I will use quotient rule. So what's the quotient rule here? The bottom part, you have to square it out, you will have cos power 6t. Okay, and then after that, copy the bottom, differentiate the top. So when you differentiate the top, you get a 0. Minus, copy the top, which is a 1, differentiate the bottom. So 3 is a power. When you put it in front it becomes 3. Copy the bracket, power minus 1 become 2. Okay, so you're having 3 cos t squared. After that, differentiate the cos. What do you get? You get negative sign. So negative sign t. And if you want to continue, you differentiate the t inside the bracket of the t. So you get a 1. But I didn't write out as a 1 at the end. Okay, so this is what I get. And when I try to simplify it, I will get 3 sine t cos power 2t divided by cos power 6t. Then again, you will see that you can actually try to simplify the cos square, right? So you should have sine t divided by cos power 4t. Okay, so this is the dx dt that I have. Okay, so this is dx dt only. Alright, then now let's continue. They tell you that y is equals to tangent power 3t. So what can I write is right become a bracket tangent t with power 3 outside. So when I want to find the differentiation for dy over dt, power you put it in front, copy the bracket, power minus 1 becomes square. You differentiate the thing inside the bracket, differentiate tangent, you are having secant square. Differentiate the t, you have a 1. Okay, so this is what I have for 3 tangent square t secant square t. Okay, so this is my dy dt. Okay, alright, then now let's continue. they want you to prove that dy dx is equals to sine t. Okay, so what is dy dx? So dy dx means dy dt. So this is dy dt multiply with dt dx. So dt dx, this is dx dt. dt dx means cos power 4t divided by 3 sine t. Okay, so my final answer that I want is sine t. Okay, so that means for all the equation here, if possible, what I will do is that I will try to change everything into sine and cos. So 3 is a 3, I just copy. Tangent square, it will become sine square t divided by cos square t. So this is tangent square. Okay, now for secant square, what do you have? You have a 1 over what? Okay, secant square means cos square t also. Then multiply with cos power 4t divided by 3 sine t. Okay, so once you expand everything in terms of sine and cos, then you try to simplify. Cos power 4 can be cancelled off with this. 3 can be cancelled off with this also. Sine square can be cancelled with sine. And therefore, very easily, you will see that your final answer is sine t. Okay, so this is what I have for my answer of dy dx. Okay, so we are done for the first part. Okay, then for the second part, what they want. Okay, so for the second part here, they want you to find the equation of tangent, and they will show that this is the equation of tangent that you will get. Okay, all right, so we will start now. Okay, so to get the equation of tangent, what you need is like the x and y coordinate and also the gradient. Okay, so for this question, they didn't tell you what is the value of t that they want to use. Okay, they only ask you to find the equation of tangent. So if they didn't ask you to use, they didn't tell you the value of t, then generally what you need to do is like just substitute something general. So the dy dx, this is the gradient of tangent. All right, so maybe I will tell you that this is gradient of tangent. Okay, then what happened to the coordinate? So the coordinate that you are going to use is the equation of the parametric equation, because they tell you x coordinate is 1 over cos power 3, y coordinate is y equals to tangent power 3. So this is the x and y coordinate. This is the gradient of tangent, and I'm going to use this information to form the equation of tangent. Okay, so to get the equation of tangent, the formula is what? The formula is y minus y1. So your y1 is tangent power 3 equals to m. M is gradient sine t here. Okay, and then x minus x1. So the x1 is 1 over cos power 3t. Okay, so this equation looks not so easy, but they want you to rephrase it something like this. Okay, so maybe you can try slowly. Okay, the first step that I can do is like maybe I expand the bracket on the right hand side. So sine t times x, I'm having sine x sine t. Then minus sine t divided by cos power 3t. Okay, so maybe this is what I have. Alright, and then after that, if you compare your step with the answer that they want you to find out, okay, y is there already lah. Y is here. Can see that? X sine t. Already have x sine t. So now the remaining part now, you need to change the remaining part to become negative tangent t. Alright, so you can always compare your solution with the steps so that you roughly know what should you do next. Okay, so for me, I will try now to move the tangent power t over. It will become plus tangent power 3t minus sine t over cos power 3t. Okay, all right. Then next, how can you change this into tangent t? So again, you need to really know all the formula, all the identity very well, so that you know how to continue from here. Okay, all right. So what can I do now is, wait Okay, so what can I do? All right, so maybe I try to make this one. Okay, I need to show it to you. For sine over cos power 3, I can write it becomes sine t over cos t times cos square t. So cos t times cos square t cos power 3, right? Okay, then for this part, sine over cos is what? Sine over cos is tangent. Okay, and then you have tangent. So this is tangent t. And then what happened to this one? This one is 1 over cos square. So 1 over cos square, you have secant square. So that means this fraction, you can change it become tangent secant square. Okay? So I will substitute it here. I will have tangent t multiplied with secant square t. Okay? Then now, why do I need to change it like this? Because I know that I can try to factorize out the tangent t. Okay? So that because both also got tangent t, so I can actually try to factorize out the tangent t so that I'm getting one step closer to the answer that they want. Okay, and then another thing is because I know that this is negative, alright, so what am I going to do now is I want to factorize out the negative tangent t. Okay, so I don't want the plus anymore. I want to make it become negative tangent. So when I want to factorize out the negative tangent t, then the secant square t become positive minus tangent square t. Right? So next, until this step ready, okay, how can you simplify further to get the equation that they want us to show? Okay, so okay, you might need to think about all the identity that you learned it before. I don't know whether you still remember or not. Okay, so the hint for this one is actually we learned one equation before, which is tangent square t plus 1 equals to secant square t, right? Therefore, secant square t minus tangent square t, it is equals to 1. Therefore, this whole thing is actually a 1. So the answer is up. Is there, right? So you can see that the answer for the equation of tangent should be x sine t minus tangent t. Okay, so this is how we do it. So for this example, it looks like a bit complicated because you need to apply a lot of trigo functions and also the trigo identity. And again, if you don't have any idea about all the trigo identity in your mind, right, that is quite hard for you to continue and solve. So as what I suggested before, you have to try to memorize all the trigo identity now. All right, and this kind of question now, because there are a lot unknown and then it looks like quite complicated for you to reach the answer that they want. So again, practice more and also memorizing all the identity will help you better in solving all these kind of questions. Okay, so usually for the differentiation that involves trigo, usually the question will be slightly tougher. That means you need to think about a lot of the identity to get the answer that they want you to show. Okay, so this is what we have for the parametric differentiation. The question can be very easy like the previous example that we discussed just now. And then this one is a slightly harder question. Okay, and then so for our syllabus, A2 syllabus, this is what we have for all the differentiation part. Okay, so again, for differentiation, every year they actually contribute quite a number of marks in the test paper, in the exam paper. So please make sure that you are very familiar with all the details, all the application for the differentiation, okay, so that you can score better for your exam paper. Alright, so here we ended our chapter 4 syllabus. In the next video, we are going to continue with the new chapter. Alright, so see you in the next video then.